Hello guys, today we are going to start a new topic. We're going to talk about graphing linear inequalities. You may recall in the past we graphed linear equations, and graphing inequalities is going to be almost the same with just a few minor changes. So just to recall, when we did graph equations before, we plot 2 points, we connect them with a solid line. You can see here that when we are graphing, the line part is going to stay the same. However, the inequality is going to have some shading because there are going to be multiple, or we know that there are multiple solutions for an inequality. And so the difference is that after we graph the line, we're either going to connect it with a solid or a dotted line. I'm going to tell you how to determine which. And then you're going to shade on one side of the graph. You're either going to shade above or below, depending if your symbol is less than or greater than. So for instance, here, if you have the greater than or equal to, the equal to means that we're going to draw a solid line, and then greater than means that we would shade above. So if it's greater, we shade above the line. If it was less than or equal to, it is still going to be a solid line because it is equal to this line, and then we would shade below because it is less than. So anytime you see the equal to with the inequality symbol, you're going to use a solid line. And if it is greater, we shade above, less, we shade below. If we have just the less than or greater than sign without the equal to, then we will use a dash line, right? And so any points that are in the shaded region are a part of the solution set, meaning that if I plug those values in, the inequality will be true. Because this is a dotted line, any points on the dash line will not be true. So the only solutions are the ones in the shaded area. Whereas if we do have equal to, the points in the shaded area are solutions, but the points on the line are also solutions too. So the difference here is that if it is equal to, the points on the line are included. If it is not equal to, then the points on the line are not included in the solution set. So how do we know if a point is in the solution set? What we can do is we can test it. What should happen is when we plug the x and y value into the inequality, then we should get a statement that is true. For instance, I'm given this inequality. Y is less than negative 2x plus 3. And I want to know is 10, 7 in the solution set. So 10 is in the position of x, 7 is in the position of y. So I'm going to plug those things into the inequality. I replace y with 7 and I replace x with a 10. And then if we work this out, we'll get negative 20 plus 3, which is negative 17. And so we will be left with 7 is less than negative 17. Well, that is false. 7 is not less than negative 17. So then that tells me that 10, 7 is not in the solution set for this inequality. I can test the same point before a different inequality. And so again, I'm plugging in 10 for the x and 7 for the y. And when I do that, I'll get 3 times 10 is 30, minus 2 times 7, which is 14. Then 30 minus 14 is 16. And so we get 16 is greater than or equal to 8, which is true. So that means that 10, 7 is a solution. So what that would mean is that if we graph this, 10, 7 would be a part of that shaded area. So I know that it's a solution. If we were to graph this first one and we were to plot 10, 7, it would be in the non-shaded area because the non-shaded area are things that are not solutions.